AP Chemistries, this is Mrs. Vanderlei bringing you Blankwalle, Chapter 13, Section 6, Part 2. So we're talking about reaction mechanisms, and we left off talking about how to determine which is your slow step and things like that. So let's see what problem number 30 has to say. So if nitrogen oxide is reduced to hydrogen to give water and nitrogen gas, and one possible mechanism to account for this reaction is the following, step 1, 2, 3. So what is the molecularity of each of these three steps? All right, well, let's do that one first. So how many things must collide to get the first product? Well, it looks like I need 2 NO, so 2 means bimolecular. Well, how many things have to collide in the second step? Well, 1 and 2, so that's also bimolecular. And what about number 3? Well, I have one of these and one of these, so it is also, bimolecular. Okay, so they're all bimoleculars. So then what? Show that the sum of these elementary steps is the net reaction. Okay, so what can I cancel out? Why don't you take a minute out and do that on your own? Okay, hopefully you got it. So we have NO2 or N2O2 are, what do I call those? I call those intermediates, right? Because they are created, then used up. Is there anything else I can cancel out? Looks like N2O and N2O. They can also be created and then used up. So is there anything else I can cancel out? No. So what's my overall reaction? Well, if I add up everything over here, looks like 2 NOs plus 2 H2s. And what's left over here, I get 1 N2 and 2 waters. All right, so here we go, N2 plus 2 waters. So that's my net overall reaction. Okay, what about problem number 31? Okay, it says the balance equation for the reaction of gases nitrogen dioxide and fluorine is here. Here is the rate law. So notice that, that this right here does not match the rate law, okay? Because here I have 2 NO2s and here I only got 1 here. So let's look at the suggested mechanism. All right, so a suggested mechanism for this reaction, here we go. We have a slow and a fast. So is this an acceptable mechanism? Does it satisfy the 2 requirements? Justify. All right, so go back to the beginning of the section and what were the 2 requirements for this to happen? Well, first of all, that your elementary steps need to do what? Cancel out to get the overall reaction. So, there it is. So do my elementary reactions cancel out to make this? Check that out. Go ahead and do that. So I have only the F's are being canceled out. Those are my intermediates. So I have 2 NO2s plus F2 makes 2 NO2Fs. Is that what is up here? Yes, it is, okay? So the elementary steps are going to cancel each other out to make the overall reaction. That works. What was the other requirement? Look at your slow step, all right? What do you get? NO2 plus F2 are your 2 reactants. Okay, so does that match the rate law right here? Well, I have 1 NO2 and 1 F2. I have 1 NO2, I have 1 F2, so the answer is yes, the slow step matches the experimentally determined rate law. So does it satisfy the 2 requirements? And the answer is yes, so that is an acceptable mechanism, okay? Let's go on to the next page. And this is a former AP question right off of an old exam, and I think that we will start tomorrow's class by doing this problem together, okay? So that's it for section 13.6. Don't wait to be great. You knew I was going to say that, didn't you? So we'll see you next time. Bye-bye.